Today, I want to just kind of talk about the final review and Blackboard in your class. You got your book here and your PowerPoints and your videos. I added a new folder here called Final Review. If you open up this folder here, it'll have a document, Final Review document. This is the document I'm going to use to give you kind of a walkthrough for the final. So if you want to print this out before you watch my final review, you can watch this, or you can print this out, and then you can make notes on the final review on this document, and you can use these notes as you take the final. So remember, the final is using a lockdown browser with the camera microphone, but you will be allowed to kind of reference any kind of notes, and you are allowed to use your graphing calculator. So to begin my final review, again, this is the review that you'll see in your MyLab statistics. I'm not going to do every question in MyLab. I'm just going to pick a few. The questions involving vocabulary, just make sure you make notes on those vocabulary words and make sure you understand those key vocabulary words as we move into your final review. What I will basically focus on is the kind of things that you may have to use your calculator and some of the math that is involved in statistics. So again, as we move into this, you took a statistics class, so hopefully one of the things you kind of pick up on is this definition of statistics. So statistics is the science of collecting, organizing, analyzing, interpreting data in the order to make decisions. So remember early on we were doing, collections using tables and graphs. That's a big part of it all, collecting and organizing. Nice thing about collecting, though, is they usually collected all the data for us. In the real world, you'd have to go out and do that collecting, and you'd have to try to figure out how to best get that random sample to kind of make your data be as useful as possible. Analyzing, we did a lot of stuff, mean, and the standard deviation, the variance, and we also used the normal distribution for a lot of it. That helped us to interpret a lot of the data, and then make decisions. We got into some hypothesis testing as well towards the end. So the branches of statistics that we mainly focused on is descriptive statistics and inferential statistics. Descriptive statistics is the branch of statistics that involves the organization, summarization, and display of data. So that's the first part of the book that we did. And then the inferential statistics is the branch of statistics that involves using a sample to draw conclusions about a population. And again, the basic tool in the study of inferential statistics was that probability. So remember, we got into those counting principles of permutations, combinations, and things like that. And then we got into the normal distribution curve, because remember the area under the curve was the probability of something happening. So a lot of it got into the probability, and most of it was under the normal distribution curve, because that's where all of our probability is found under that curve. So the first question I want to look at on your review is question number 5. This comes from chapter 2, Descriptive Statistics. So the first thing you're going to be asked to do is you're going to use the data set listed and technology to create frequency histograms with 5, 10, and 20 classes. So that's one of the things. One of our goals is to figure out how do we do that, if you recall. So I'm going to use the calculator to do this to start with. So I hit stat, and under stat we use number 1 for edit, and then we have these lists. So this is going to be just one variable statistics. So we're just going to be putting things in L1. So I'm going to clear off L1 and put new data. Actually, this data is already there, so I'm going to keep this data in here. And I'm going to pause a second to make sure I've got everything I need here. So let me back up on this for a second. So yeah, I've got my data in here already. One of the things, when I inputted my data, I also sorted it. So when I hit stat, number 2, if you choose number 2 there and sort, So sort, notice how we have L1, L2, L3. If I had second L1, close parentheses, hit enter, notice how it says done. That means my L1 list should be now sorted from ascending order, which means from smallest to largest. So if I go to stat and go back to edit, notice that my minimum value is 1. Notice how there's 3 ones. We have a 2. We have some 3s, some 7s, 9s, 10s, 11s, and we have a 15 there. So what we want to do is, using technology, we want to create a frequency histogram. So with 5 classes. So what we can do to start with is, make sure we use our stat plots, number of stat plots above this y equals button. So that second stat plot, what we want to do is we want to turn on plot 1. So if I hit enter, notice how mine is on already, but if yours is in the off position, notice if I hit enter, if it's in the off position, come over to the on position, hit enter again. So notice how we have these different types, of our data. The histogram is the one that looks like that. It's kind of like those attached little boxes, if you will. So I hit enter there. Notice that my X list should be 1. The frequency should be 1. And we have that going on. So if I hit zoom, number 9 is, that'll do our statistics. So if I choose 9, it'll generate the histogram. Notice how it does 1, 2, 3, 4, 5, 6. It's got 7 classes. So what we got to do is figure out how to make this change to 7 classes. So it's all about what we call the class width. So to do a class width, what we have to do is we have to do the max value minus the min value divided by the number of classes that we want, which is 5. So that our largest value was the 15, our smallest value was the 1. So if we go 15 minus 1, that's going to give us this 14. And if we divide that by 5, so I'll let the calculator do that for us. So I hit second quit here for a second. 14 divided by 5. And that would give me 2.8. So we round up to the nearest whole number. That's going to give me then this 3. So I have a class width of 3. So this gives me my class width. So what I want to do is, in technology, like so if I go back to, if I hit back to zoom, and that number 9 gave us this here, what I want to do though is I want to change my viewing window. So to change my viewing window, that's where it says window. So if I hit just the window button, notice what I really want to do is I want to change my X scale. Instead of saying 2.33, I want to change my X scale to go by 3s. I shouldn't have to change anything else except that. If I hit graph, notice how it now gives me 1, 2, 3, 4, 5 classes. Now, if I hit the trace button, it'll kind of tell me that my first one, I have a min of 1. But notice how this class width is going to be less than 4. So I have a 1 here. Let's see. I'm sorry. Let's see here. How do we interpret that? 1, n equals 8. N equals 2. So that's the number of pieces of data in that area. So that the height of that's going to be the 8. And then, here and here, we're between 4 and 7. And the number of pieces of data in there are 2 pieces of data in that area. Notice here we're between 7 and 10. And we have 6 pieces of data there. Here we have between 10 and 13, we have 6 pieces of data there. And between 13 and 16, we have 3 pieces of data there. So that's kind of where it plays out. So that's our window. So, between 13 and 16, notice how that would be the 13, the 14, and the 15. That would be the 3 pieces of data that's in that area of the histogram. So anyway, if I want to create a histogram now with 10 classes, it's going to be the max minus the min. So it's still going to be 14. But this time we're going to divide by 10. So if I hit second, quit, if I do 14 divided by 10, if I hit then equals, that gives me 1.4. So that round up to 2. So hopefully we see something to that effect here. So if I go to my window again, I need to change back scale this time to 2. Nothing else really have to change, I don't think. I think we go out far enough there. Max, I may want to go out a little bit further there than that. So let's say we go out to maybe 26 or something there. But I don't think we have to really change anything else. So we should have now 10 classes. So 1, 2, 3, 4, 5, 6, 7, 8. And then the rest of them, you would not have anything in them. So really only 8 show up here. So we kind of go, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So 20 would have been enough as far as classes go. So we have something like that. So if I hit the trace button, notice how we have between 1 and 3, we have 4 data pieces there. Between 3 and 5, we have 5 data pieces there. Between 5 and 7, we have 1. Between 7 and 9, we have 4. Then we have between 9 and 11, we have 6. And then kind of so forth and so on. And notice how then we have like zeros there. So if I go ahead and do 20 classes, so if I do 14 divided by 20, so if I go back to my window here, 14 divided by 20, notice that's going to be less than 1. So if we round up, that's going to be, the class width is now just going to be 1. So to make my class width, what I did is go to the window, I changed back scale this time to 1, and that'll generate my histogram for me. If I had a graph, that's what my histogram should look like, is something like that. Again, you hit the trace button and kind of get these values. So pay attention to your graphs, those high points. There's 3, 1, 1, 4, 1, 0, 1, 3. So pay attention to those high points and make sure you look at the scales on the histograms in your graph, and you can kind of choose those respectively. Okay. All right. So question 7 is the next one I will look at. So this is going to come from section 2.2. This is going to be the stem and leaf plot. So the data shows the ages of all participants in 2 yoga classes, completes parts A through D. I'm just going to do the stem leaf plot. Nope, I've got it all here. So we'll kind of do it all. So the first thing I want to do is make a back-to-back stem and leaf plot to display the data. So the catch is it's also got to be in what we call some type of order. So here we have 0 is going to be these are going to be the stems here, the 4, the 6. So I have 0, 1, 2, 3, 4, 5, 6, 7. I don't know if we go past 7 or not. 76 is about all I see. I really don't even need the 0, I don't think. So one thing, since there's a lot of data here, what I will do is I will use the stem and leaf plot. But what I would do is use my calculator to organize the data. So I would hit Stat. I would hit Edit. I would actually put in L1, I would put the 3 p.m. class in there. So I'll clear this off. So I'm going to pause my video for a second. I'm going to put this data into the calculator. So I've got my 3 p.m. class listed here. What I want to do again is hit Stat and use number 2 and sort L1. Now, if you can do this without doing this, that's fine. But if I go back to my stat and look at my list, what I can see now is my list. So my stems, I've got nothing in 0, 1, 2. What I have is I have like a 35 and a 38. So I have my 5 and my 8 out here, so those become my two leaves there. I've got a 41, so I have a 4, 41, 51, so 51, 53. There's a lot there, so I may want to see if I can squeeze them into 51, 53, 55, 59. Make sure you don't put a comma after that 9. That's where I mess up sometimes. I put an extra comma in there and it doesn't like that. Then in my 60s, I've got a 60, so a 0, a 64, a 67, a 68, a 68, and a 69. Again, no comma after that 9. And then the 70s, let's have a 71, 73, 73, 74, 75, 76, 77, 77. So I want to do that the same with my other class as well. So this is the 3 p.m. yoga class. So I've got 35, 38, 41, 51, 53, 55, 59, 60, 64, 67, 68, 68, 69. So you kind of see that how that reads there. So I want to do the same thing, and I want to put my 8 p.m. class in. I'm just going to go ahead and clear this one off here and just put in a new one there. I've got my data now in front of me. So I'm going to pause again my video and get that data in, and I'm going to sort it. And so I've entered my data for the 8 p.m. class. Again, I'm going to hit the stat. I'm going to choose number 2 and sort it. Again, I'm going to just sort L1 and do that. And then if I go back to stat and just hit the edit button, it'll show me my stems and leaves here. So I have this, so back to back. So now I have an 18, an 18, an 18, a 19. Oops, don't need both of them, just need the 9. And make sure you put those commas in there. Let's see here. So at 18, I got 1, 2, 3 18s, 1, 2, 3, 4 18s actually. 2, 3, 4 19s. So 1, 2, 3, 4 9s. But don't put a comma on that last one though. So the 20s, we have 2 20s, and we have a 22. And what else do we have here? Last one there. So now we're in the 30s. 31 and a 36. I've got a 43 and a 44 and a 51 and a 71. So we have those pieces of data. So just by observation, you kind of see the 8 o'clock class is a lot younger than the 3 o'clock class. 3 o'clock class is a lot older than the 8 o'clock class. Those are just some observations you can just kind of tell just from the Stephen Lee plot. So again, you may want to make some notes on your thing is, you use the stat button, and we also sorted. That helps us build the stem leaf plot. I find that easier if you go ahead and put that all in there. It's easier to kind of build the stem leaf plot because on your test, the leaves have to be in ascending order. So we have to keep that in mind. So part B says, what's the lowest and highest ages of participants in the 3 p.m. class and the 8 p.m. class? So in the 3 p.m. class, lowest would be 35, and the highest would be the 77. You kind of double check that if you need to look back up there. Yep, that 35 and 77. Don't have anything lower than those. The 8 p.m. class, low 18. The 71-year-old. That's kind of like an outlier there. So how many participants for each class? So in the 3 p.m. class, you would just be counting the leaves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. You can also double check up here, should have 22. So it's like 1, 2, 3, 4, 5, 6, 18, 19, 20, 21. So should only have 21. So let me double check down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I think I counted that 7 there and I shouldn't have. So you almost have to kind of maybe box off your stem so you don't count it. So I had 21 in my 3 p.m. class. In 8 p.m. class, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Or if we go up here, we can kind of see 1, 2, 3, 4, 5, 6, 12, 18, 24. It's almost easier to count that one up there in the actual table. So there's 24 participants here. So compare the distribution in each class and what observations can you make? So again, here it's kind of just the observation. I'm not gonna write it down, but it just seems like the 3 o'clock class, the ages are much higher than the 8 o'clock class. That would be one of the observations I can make from there. Okay. Pause a second here. So last thing we're going to do chapter 2 is measures and variation. So the ages in years and heights in inches of all pictures for a baseball team are listed. So notice how it said all pictures of a baseball team. So this means we actually are counting all the data. This is not going to be a sampling. So find the coefficient of variation for each of the 2 data sets, then compare the results. So since we are actually counting all of the pictures, we're going to be using sigma and mu, because remember, those are population's standard deviation and population mean, where S and X bar, S would stand for the sample standard deviation and X bar would be the sample mean. So we're going to be using this one. So again, the way this is going to work is we're going to actually have to use our calculator and put the stat in. So I'll be using the stat button. I'd be going to 1. I'd be clearing off this list. And here I'm going to actually put in an L1 and an L2. So L1 is going to be my heights and L2 is going to be my ages. So I'm going to pause my video again and put that data into the calculator. So this question is asking us to find the coefficient of variation. So we have some formulas here out of chapter 2, section 4. So again, if you print out this document, which is in your Blackboard, you have these formulas already available. But if you're going to make your own notes, then make sure you have these 2 formulas written down and note that they are for the constant of variation. So again, notice how we are using, since we are counting all the pictures of a baseball team, this is going to be the whole population. This is not going to be a sampling. So we're going to be using sigma and mu here for those. So if I go to stat, go to calculate, we're going to be doing one variable statistics. And the heights is in L1. We don't have a frequency list. So we're going to just hit calculate. And this gives us our stuff here. So what we want though is we want sigma divided by mu and multiplying by 100%. Really all we're doing is multiplying by 100. And we're just going to stick on the percent symbol. Okay. So using our calculator, we can actually type in sigma divided by mu. So sigma is the sigma x, which is this 2.7. Now, if I don't want to round it, we can use a special button. And mu is going to be actually the same thing as x bar up here. They're actually the same on this calculator. So it's going to be our population mean as well, since that's all data pieces. So if I hit vars, number 5 gives us these symbols. So if I choose number 4, and if I divide that by, hit vars again, choose number 5, and use x bar for mu, that'll give me sigma divided by mu. If I hit enter, that'll give me this here. Then if we multiply that by 100, that'll change this into a percent notation. So remember to put the percent symbol down on. So usually that's going to be part of my lab. So watch out for that. You might have it. So that's going to be like 3.7%. That's going to be the constant, the coefficient of variation. So the heights are not varying by a whole lot. And if you think of heights in baseball, most people are basically around the same height in baseball. Now, basketball, there may be a little bit more variation than there is in baseball. So if I want to now do the, this is going to be for the heights here, 3.7%. So if I now go and hit stat again and use calculate one variable, but this time if I change my list to L2, second L2, I don't have to do anything else there. Hit calculate. It'll give us our stuff again. So again, we're just using sigma over the mu. So again, if I hit vars, number 5, that'll be number 4 divided by, if I hit vars again, number 5, number 2 for that. That'll save me the trouble having to write those numbers down. Hit enter. Again, when you multiply by 100, that's just moving the decimal 2 places to the right. So for the ages, and you should pick up on, there should be a bigger variation in the ages. So they're saying like 12.6%. So ages vary a lot more than heights, and that would make sense. That would be kind of my conclusion there, that the heights are not varying as much as the ages. The ages are varying a lot more than the heights. Okay, so we have that kind of going on there. So again, some key buttons again is, we hit stat, and we made a note that we use the calculate button inside there. Make sure it's L1 or L2 in our list there. And also you can use the vars button for those symbols. You don't have to use the vars button, but you can use the vars button to actually do the math that way. All righty.